Friends, to our discussion on logarithms. Now we have completed 4 units, and now this is the next unit that we have to discuss. We have already had an exposure to logarithms and anti-logarithms. So what we will be doing is we will be only briefly discussing the basics of logarithms and anti-logarithms, and then we'll also talk about the operations in logarithms. So shall we start our discussion? Now, first thing that we need to understand is why basically do we use logarithms. There has to be some reason why logarithms are required, why they are actually used. There has to be some reason. So let us try and understand. Let us find out whether you would be able to guess why we basically use logarithms. What is the use of logarithms? See, I'll give you a rough figure. Log 10 base 1000. Now please understand that this thing which is in the subscript, this is called the base. So this is log 10 base 1000 and the value of this is 3. So if I want to convert a number, this number is 1000. I want to convert this number and I'm making use of logs and I'm making use of the base 10, then 1000 would be equal to 3, right? What will be the case here? Log 10 base, now again the base is 10, there could be other bases also, there could be 2, 4, there can be so many bases. But when nothing has been mentioned, you should assume that this is basically, the base is 10. Because if the base is 10, it may not be mentioned. So if nothing has been mentioned, you have to assume that the base is 10. In case the base is 2 or let's say 6 or maybe some other number, then it would be mentioned here. However, in this case, the base has been given, it is 10, and we are trying to find out basically what is the value of this particular number. This particular number is, have a look at it, it is 1 lakh, and log 10 base 1 lakh is equal to 5. Then let's have a look at this particular number. Okay, so this is more than 100 crores. So now if we use logs to express this number and we are using the base 10, then the value is equal to 10. So the log of this number is just 10. Now can you guess why we are making use of logarithms? Many a times that the values which we are dealing in, they are so big that it's just not easier for us to express them, to write down these values every single time. So what do we do in such places? We convert them into their log equivalents and then we express them as their log equivalent. So the log equivalent of, we had discussed this one, log equivalent of 1 lakh is just 5. So if I mention 5, this is the log equivalent of 1 lakh. So rather than writing down 1 lakh every time, I can simply write the log equivalent, then the log equivalent is 5. Is this understood? Now think of, suppose you want to calculate the distance between the earth and the sun. Don't you think it would be a very big number? And don't you think it would be easier for us to express it in the form of logarithms? You understand my point? If you want to talk about the number of you have heard of the Avogadro number, these are terminologies in science, and if you want to deal with these kind of values, naturally these would be big values, so you can make use of logarithms, right? And that is why we make use of logarithms. But the point is that once you have converted, let's say let's discuss this particular example. So suppose we have converted 1000 into 3 and we are expressing it as the log equivalent of 1000 and we are saying the log equivalent is 3. I would also need to convert it back. I have converted in one direction, but then I would want to convert it back. And how do I do that? For that I will have the opposite of logarithm and the word for opposite is anti, and that is why I make use of anti-logarithms. You understand my point? So the anti-logarithm in this particular case of 3 is going to be 1000. The anti-logarithm of 5 is going to be 1 lakh. Is this understood? So this is why we use logarithms, and then again why we also have to use anti-logarithms, or the anti-logs in short. So I've mentioned to you that I've got a big number. Then what do? I have to convert it into a logarithm so that it becomes manageable for me. So I do that. So I'll be making use of a log table to do this. But if somebody wants to find out, if I have this logarithm now with me, and if I want to find out the number from which it actually originated, then what will I have to do? I will have to make use of anti-logarithm. Is this fine? So this is how we convert a number into its log equivalent, and the log equivalent can be converted back to number using the anti-logarithm. And we have got specific tables for it, the logarithm table and the anti-logarithm table. So this is just a brief idea as to why we use logarithms and anti-logarithms. Now I am moving on to finding the logarithm of a number. So the first thing that you need to keep in your mind while finding the logarithm of a number is the characteristic. Here the characteristic does not mean feature or attributes. Characteristic is a particular term here which is being used to denote something. So let's have a look at what characteristic denotes. It is the integral part. Integral word has actually originated from integers, and it's a natural number. So characteristic is basically a natural number. It's an integral part. It is basically some kind of an integer. It's a natural number, and it is determined by the position of the decimal point. So for example, if you want to convert a number into its characteristic, the position of the decimal in that number will determine the characteristic of that number. And how do we do this? If the number is greater than 1. Now please understand, this is something that you'll have to bear in your mind. The characteristic will be positive. Again, now this is important. And it would be 1 less than the numbers before the decimal. You just read it and try and understand it. We'll be taking up examples and you will understand how to actually find out the characteristic. So it is 1 less than the number before the decimal, and if the number is less than 1, the characteristic would be negative, which means that the characteristic can be both positive and it can be negative as well. And how do I find the characteristic? Negative would be the sign, and the characteristic would be 1 more than the number of zeros between decimal and first non-zero digit. We'll understand this. So let me take this particular example, 430700. Now this is a number which is greater than 1. Naturally you can understand this also, that it is basically a number which is greater than 1, which means the characteristic is going to be positive, right? So the characteristic is going to be positive, so I put a plus sign here, right? And it would be 1 less than the number before the decimal. Now 430700, where is the decimal? It's basically after this 0, right? So this is where the decimal is. And how many digits are there before the decimal? There are 6 digits. So 1 less than the numbers before the decimal. There are 6 numbers before the decimal. 1 less is 5, and that is why the characteristic is 5, and this is positive 5 because the number is greater than 1. Now let us see whether you can do it on your own now. How many numbers before the decimal? 4307. Actually the decimal is somewhere here, so 4 numbers before the decimal, which means that the characteristic would be equal to plus 3. Since if no sign has been given, it is assumed to be plus, so plus has not been mentioned here, but you can now understand that this is basically positive. So the characteristic here is positive. Now have a look at this one. 2 numbers before decimal, and 2 minus 1 is 1, so the characteristic is 1. How many numbers before decimal in this example? 1. 1 minus 1, 0, right? Now in this case, now this is a slightly different case. This is a case where the number that has been given to us is 0.4307. It is less than 1. 0.4307. It is less than 1. What does this mean? That we will have to go by this particular rule, right? The characteristic would be negative. So it is indeed negative, the sign you can see here, and it would be 1 more than the number of zeros between decimal and first non-zero digit. This is the decimal, and where is the first non-zero digit? Non-zero means 1, 2, 3, 4, 5, 6, 7, 8 or 9. So the first non-zero digit is this one, right? And how many digits are there between decimal and the first non-zero digit? There is 0. There is no number between decimal and first non-zero digit. So which means the number of zeros between decimal and first non-zero digit is basically 0 here, right? So you'll have to add up 1. So it is 1 more means you'll have to add up 1, and that is why this 1 has been mentioned here. And negative we have already understood, since it was less than number, this number was less than 1, that's why, right? Now let's have a look at this one. You might find it a little difficult to follow in some places. Please stop the video there and then, pause it, have a look at it again and again, listen to the video again and again, so that you better understand, right? Now let's talk about this particular example here. Now naturally it is less than 1, so it's got to be negative, so that explains the negative here, the negative sign here. Now